want to talk about differential calculus. Where we start is limits. So let's have just first example about limits. Evaluate 7 minus 2x plus 5x squared minus 4x squared at x tends to 0. So this is how to do this. You set limit 7 at x tends to 0 minus 2 limit x tends to 0 plus 5 limit s squared at s tends to 0 minus 4 limits at s tends to 0. You'll be putting it one by one. At the limit where there is a constant like this 7, it will also give you 7. It will be 7 at s is equal to 0 minus 0, 2 times 0, s squared is 0, that is plus 0. This also minus 0. So everything is equal to 7. So the literal meaning is just to just put the value of 0 to the x. That's all. That's about the limit. Let's have another example, like example 2. Under the limit, evaluate lim x tends to 0 to s squared plus 5x plus 9 all over 2s squared minus 3x plus 15. For solving this, you'll be doing it one by one. Whereby we have solution, said limbs s squared at s tends to 0, you put it one by one, plus 5 lim x tends to 0 plus 9 limit x tends to 0. The same thing we are applicable to denominator onto 2 onto s tends to 0 s squared minus 3 lim x tends to 0 plus limit 15 s tends to 0. So you do it one by one. You're able to see this, that this will be 0 because s squared is equal to 0. This will also be 0, but this the only constant we escape. And also here, this is only constant, the one that have s, because as h tends to 0, not s equal to 0, when h reaches 0, tends to 0, so therefore the final answer will be 9 over 15. So for writing this, it will be 0 plus 9 all over 0 minus 0 plus 15, which is equal to 9 over 15. So that is all. Let's also have another example. Let's have example 3. Said evaluate at the limit of s squared minus 25 over x minus 5 as x tends to 5. Now, for solving this, you just have to apply it in algebraic form, meaning that lim x tends to 5. This is the difference of 2 squared. This is x minus 5. By the time you simplify onto x plus 5 all over x minus 5. So you discover that this will cancel this. So lim x tends to 5 of x plus 5 will now be 5 plus 5, which is equal to 10. So that is how we find the limit. So I will also want to solve the last example. Let's say let me have example 4. Let me have example 4. Said lim as s tends to infinity, where we have s cubed plus 2s squared plus x plus 1 all over s cubed plus 2x plus 5. Solution. We all know that at a limit of 1 over x, when x tends to infinity, is equal to 0. So to be able to have gotten this value, because this is an infinity, let's try to do something and say that in the numerator, s cubed is common. If s cubed is common, it means it will remain 3 plus, so s cubed, this one will give you, it will give you 2 over x, because by the time you multiply s cubed with this, it will give you 2s squared. This one will give you plus 1 over s squared. This will give you plus 1 over s cubed. That is for the numerator. For the denominator, let's also remove out s cubed. We said 1 plus 2 over s squared plus 5 over s cubed. So by the time you multiply s cubed with this, it also give you 5. By the time you multiply s cubed with 2 over s squared, it will also give you 2x. So we are only using the logic. And we all know that the is a lim at s tends to infinity. So since you know that this one limit of 1 over x will surely give you is 0. So the first thing you do, you cancel this and this. We have limit x tends to infinity. S tends to infinity now remain 3 plus 2 over x plus 1 over s squared plus 1 over s cubed all over 1 plus 2 over s squared plus 5 over s cubed. So now, you know that 1 over x is, so let's try to rearrange to get it better. Let's say we have limit s tends to infinity. This one can also be rewrite as 3 plus, you're able to see now, 3 plus 2 onto 1 over x to bring it out. Now plus, let's see, this is 1s squared and you need 1 over x. You can also rewrite this in this form, that 1 over x onto 1 over x. Both of them will become 0. So therefore, this one will give you plus 1 over s squared times 1 over s. So what you just need is that 1 over x, because you know that 1 over s is 0. So 1 plus 2 over x onto 1 over x plus, so we have 5 over s squared onto 1 over x. So which one does not have 1 over x after applying the limit? It is only the one of 3 and 1. So therefore, it will be 3 plus 0 plus 0 plus 0 over 1 plus 0 plus 0. So it will now give you 3 over 1, which is equal to 3. So before, this is just how to explain limit in differential calculus. So before we proceed, try to subscribe to this channel. So for the next video, you're able to get it easily and able to get to know what we are explaining in this place. So this is about the limit in differential. Now we want to discuss about differentiation from first principle. Let's have this example 1. Differentiate the following from the first principle. A, y is equal to s squared. B, y is equal to s cubed. C, y is equal to 1 over x. D, y is equal to c. That is how to know the derivative of constant. E, y is equal to ax plus b. Let's start solving this. So if y is equal to x squared, the first thing you do is set y plus change in y is equal to x plus change in x whole square. So therefore, our change in y will be x squared plus change in x minus y all square. So the expansion of this, the expansion of x plus change in x, it will give you x plus change in x onto x plus change in x minus y. So it will be x squared plus x dx plus x dx plus ds squared minus, what is the value of y? You back to the question. The value of y is s squared. You notice something, that this is plus s squared, this is minus s squared. So by the time you add this and this together, it will give you 0. It will now remain 2s ds plus ds squared. So therefore, meaning that dy is equal to 2x dx plus ds squared. So at this place, what you need is dy dx. That is what we need, because we are differentiating with respect of x. So we now have dy dx will now be 2x dx all over dx plus change in x squared over change in x. So making dy dx gives you, this we cancel this, it will be 2x plus change in x. This we cancel this to remain 1. Now as dx tends to 0, meaning that dy over dx will now give you 2x. So it means the derivatives of y is equal to s squared. From the first principle, it will surely give you 2x. Let's also solve the second question, which is y is equal to s raised to power 3. So the b part, he said, let's solve the b part now. Y is equal to s raised to power 3. You have to follow the same procedure, that y plus change in y is equal to x plus change in x all cube. I will try to do one revision, which we have to call a Pascal triangle, that if you have 1, you have also 1 here. 1 plus 1 will give you 2. You put 1, 1. 1 plus 1 will give you 3, 3, 1, 1. So this thing will form a triangle, which we call Pascal triangle. Pascal triangle. So this one, so it means that x plus change in x cube will be s cube, because of this one, plus 3x. This one has started from s cube, it will reduce to 2. You start this one with dx, plus you choose another 3x. This one will reduce to 1 from here. ds will increase, plus ds cube. So this expansion is what we need at this place. So which you now have y plus change in y is equal to s cube plus 3s squared dx plus 3x ds cube plus ds cube. So you now have the y is equal to s cube plus 3s squared dx plus 3x ds squared plus ds cube minus, what is the value of y is s cube. So you also notice something from here, that minus s cube plus s cube, you have the y is equal to 3s squared dx plus 3x ds squared plus the x cubed. So what you need is the y over the x. So to have 3x squared dx over dx plus 3x dx squared all over dx plus the x cubed over dx. So this will cancel this. This will also cancel, it will remain 1. This will cancel this, it will remain 2. So meaning that the y over dx is equal to, so it will remain 3x squared plus 3x dx. We have 3x squared plus 3x dx plus dx squared, because by the time you cancel this by, it will remain 2. So at this place, what we now need is when the x now tends to 0, meaning that this will be 0, this will also be 0. So meaning that the y over the x will now be equal to 3x squared plus 3x bracket 0 plus 0 squared. So which the y over dx is equal to 3s squared. That is about that. So we have solved the second part. That is the question B. Let's now also solve C. It said y is equal to 1 over x. So if you have to solve this, we have, that is C, y is equal to 1 over x. As you are following the step, you will also get it. Very easy to get. So as you also watching this video, I also want you to subscribe. If you are watching this video for the first time, I want you to subscribe to the channel so as we are releasing our full video topic, so you won't miss it at all. So let's start solving. It means y plus change in y is equal to 1 over x plus change in x. So the y is equal to 1 over x plus change in x minus y, which is 1 over x plus change in x minus 1 over x. So here, what is the x here? X plus change in x, we have this. So by the time this cancel this, will remain x minus, so onto x plus change in x. So meaning that the y is x minus change in x all over x plus change in x onto x. So this will cancel. We have the y is equal to minus the x all over x plus change in x bracket x. So therefore, if this is, so what we now need is the y over the x, which is minus the x all over x plus change in x onto x divided by the x. So how do you write this? You said change in y over change in x is equal to, you write, discover that it is minus the x over x plus the x bracket x times 1 over the x. Remember that you have to divide it by the x. So when you now change to multiplication, it will be reciprocate. This will cancel this, meaning that the y over the x is equal to minus 1 over x plus change in x onto x. So when change in x tends to 0, so meaning that the y over the x is equal to minus 1 over x plus 0 onto x. So x plus 0, so multiply by x, which is minus 1 over s dot x. So making by the y over dx will now give you minus 1 over s squared. So this is just the value and this is the answer. So now let's go back to the next example. So which is we are able to solve C. Let's solve D. How do we solve D? He said at a junction whereby, so the D part is, he said differentiate from the first principle if y is equal to C. This one is so very simple. What you just need at this junction is changing y plus changing y is equal to C. Therefore, changing y is equal to C minus y, which is equal to C minus C. So, changing y is equal to 0, meaning that changing y over changing s is equal to 0. So, at a limit, when s tends to 0, meaning that the y over the s is equal to 0. So, meaning that anytime you are differentiating constant, it will surely give you 0. So let's solve the last one, which is E, the E part, which is said y is equal to ax plus b. You also follow the same procedure. He said y plus changing y is equal to a onto x plus changing x plus b. So therefore, changing y is equal to ax plus a dx plus b minus y. So changing y is equal to ax plus a changing x plus b minus ax plus b. So changing y is equal to ax plus a changing x plus b minus ax minus b. So this one and this become 0. Ax and as will also become 0. They might, we call them cancel, but they are not cancelled like that. When you just add them together, they become 0. So which is a change in x. So at this junction, you divide both sides by the x because we are differentiating with respect to x. So changing y over changing x will be a changing x. So this will cancel this. So changing y over changing s is equal to a. That is the value of this. So thanks for watching. As we are continuing this class again, don't forget to subscribe to this channel for you to know more when we are sending the videos and giving another topics. This is general formula for differential calculus. If y is equal to x raised to power n, the y over the x, this n at the power or the index will multiply the base, which is nx, n minus 1. This is just the general formula for differentiation. This is exactly the formula to use. So let's solve this example. It said, find the derivative of each of the following. A, y is equal to x raised to power 7. B, s is to power half. C, y is equal to 1 over s cubed. And D, y is equal to s 3 cube root s squared. So let's start one by one in solving this. So if y is equal to s raised to power 7, as I've said from the formula, that the y over the x means that the 7 will multiply the x. You will now minus 1 from the 7, meaning that the y over the x will be equal to 7x raised to power 6. That is how we differentiate. Let's go and solve the value for b. He said y is equal to s raised to power half. That the y over the x will be, that half will multiply the base, that is the x. You will subtract 1 from the index, which is half x. So by the time we subtract half minus 1, it will still give you minus half. Minus half. You can decide to leave your answer, but you can still continue to have something like 1 over 2 times 1 over s raised to power half, because of the half from the law of indices. So we have 1 over 2s raised to power half. We can also rewrite to have 2 root x. That is the value. So let's now solve the value for C part. So the C part said that y is equal to 1 over s cubed. So if he said y is equal to 1 over x raised to power 3, so you can rewrite from the law of indices to say that y is equal to x raised to power minus 3. So you said the y over the x will give you the minus 3, we multiply the x, minus 3 minus 1, which will give you minus 3x minus 4. You can still rewrite to have minus 3 times 1 over s raised to power 4, which will give you minus 3s raised to power 4. So that is the value. That is the final answer for that. So also we still have the last one. Y is equal to 3 cube root s squared. You just have to do is you rearrange back the D part, C, D or E. So the D part, he said 3 cube root s squared. So we have y is equal to 3 the cube root of s squared. So you can able to rewrite to say that y is equal to s raised to power 2 over 3. That is just the meaning. So we just have to say that the y over the x is equal to 2 over 3 times x onto 2 over 3 minus 1. So which is 2 over 3 times x. So we have the xm to be 3, 2 minus 3. So we have 2 over 3 x onto minus 1 over 3. So you can rewrite to have 2 over 3 times 1 over 3. So which will be 2 all over 3 cube root x. So this is 3. That is just the value for this, for the how to apply the general formula. So the second part of the same general formula, we can still be written in this form. For example, we said if y is equal to ax raised to power n, when the s raised to power n as constant, you just have to follow the same procedure to say that the y over the x will be the n will multiply a x n minus 1. So this is how this will look like in a way to solve. So let's solve some example that's related to this. Let's say example 2 under the general formula. It said find the derivative of each of the following. So let's say a is y is equal to a raised to power s raised to power n. You know it's a constant. So let's do the same question, meaning that the y over the x will give you n a x n minus 1. So that is just the answer. So let's solve for b. I'll just write for b. It says that y is equal to minus 2s raised to power 3. So what you do is the y over the x will be 3 times minus 2 times s onto 3 minus 1, which will be minus 6x raised to power 2. That is the final answer. That is all. So let's also solve for c, which we have y is equal to minus 2 over 3x raised to power 4. So here at this junction, if it is x raised to power 4, so what you do here is the y over the x will be 4 times minus 2 over 3 times s onto 4 minus 1. So it will give you minus 8 over 3 times s raised to power 3. So that is all. You just have something like minus 8 over 3 s raised to power 3. So that is all about this. So that's just the answer. So let's also solve one more so we're able to get it better. So for D, for example, we have y is equal to 3x raised to power half. You just have to apply the formula that the y over the x is equal to the half. We multiply the 3 and x, that the same half minus 1, which we have 3 over 2 onto x. So half minus 1 will give you minus half. So just have to, by the law of indices, 3 over 2 times 1 over s raised to power 2. So you're able to write to have 3 onto 2 root x. That is just the answer. So don't forget more to subscribe to the channel. So as we are still continue, so you just have to get the logic that for the revision of this, that if y, the s raised to power has a constant, this is the general formula for it. So we apply it in case you have to solve a little difficult question. You just have to follow the procedure. We continue to the derivative of sum. Let's have the example straight. Find the derivative of each of the following. The first one is this. We want to differentiate the value of y respect to x. So you differentiate y to the respect to x. So therefore, with the steps of the general formula we have been able to have been used, you discover that it will be 3 times 2x, 3 minus 1, minus 2 times 5 onto x, 2 minus 1. So the constant here, it will be 0. Since we have been able to explain the derivative of constants always give 0. So the y respect to the x, we differentiate y with respect to x, that is it, notations. So it will give you 6x squared minus 10x. That is all. That is how we differentiate. Let's also have another example to have 3y is equal to 3s squared plus 1 over x. What you do, you try to apply the laws of indices plus s onto minus 1. So you make everything to be linear. You reduce the fraction part. So therefore, you said y is equal to 3s squared plus s onto minus 1. So let's apply. Let's differentiate it with respect to x, which will be 2 times 3x, 2 minus 1, plus minus 1 times x onto minus 1 minus 1, which will give you 6x raised to power 1, plus times minus will give you minus x onto minus 2. So you try to apply the indices longer, which will have minus 1 over s squared. This is just the derivative of the question of this question, so that y is equal to 3s squared plus 1 over x. So let's continue to also have another example. C, it said that y is equal to s cubed plus 2s squared plus 1 all over x. Here, what exactly you need to do, you just try to simplify first before you continue, which will have s raised to power 3 onto x plus 2s squared divided by x plus 1 divided by x. So if this cancel this, y will be x squared. This will cancel this, plus 2x plus x raised to the power minus 1. So let's rewrite the question to have, we have x squared plus 2x. We have x squared plus 2x plus x onto minus 1. That is how it is. So we now applied the general formula. Let's also do revision about the general formula. Maybe you just come across this video in the middle part that you say y is x raised to the power n, meaning that you differentiate y with respect to x, we give you nx n minus 1. So we just have this, what we are trying to apply. So therefore, let's differentiate y with respect to x, which will give you 2x plus, this one raised to the power 1. So it will be 1 times 2x1 minus 1 plus minus 1 times x onto minus 1 minus 1. So which we have 2x plus 2x raised to the power 0 now minus x to the power minus 2. Therefore, we have 2x plus, remember that x to the power 0 is 1. 2 times 1 minus x to the power minus 2. This will give you 2x plus 2 minus 1 over s squared. That's all. That's just the answer. By the time we apply, let's solve another one that you might cross across in an elementary calculus. So, which you have, let's say y is equal to root x plus 1 over root x minus 3. So therefore, if you have to differentiate this, the first thing you have to do is let's firstly simplify, which we have y is equal to x raised to the power half plus 1 over x raised to the power half minus 3. Therefore, y is equal to x raised to the power half. By the time you apply the law of indices to this, we have x to the power minus half minus 3. So now let's differentiate y to the respect of x, which we have the half, we multiply s, half onto minus 1 plus minus half times s onto minus half minus 1. So this is constant. It just gives you 0. So let the derivative of y to respect of s, which is this, x onto minus half. So this one, at this junction, we have a plus times minus will give you minus, which is minus half onto x. So minus half minus 1 will give you minus 3 over 2. That is 1.5. We give you minus 3 over 2. So let's continue simplify, which will gives, so this one will be 1 over 2 times 1 over x raised to the power half minus 1 over 2 onto 1 over x raised to the power 3 over 2. So let's continue about that. So therefore, we have, so which is the derivative of y with respect to x will now give us 1 over, this is 1 over 2 root x. That's how you write this. This one will become 2 root x. This one again will also be root. So it will be minus 1 over root x raised to the power 3. That is the level of simplifying it in indices form. So don't forget, yes, if you are new to this video, to this channel, try to subscribe for more. Now, we want to talk about what you call the composite rule in elementary differential calculus. In the composite rule, what really commons in composite rule is function of a function, meaning that function is inside a function, whereby that is how we now apply what we call a chain rule. This is a chain rule whereby the y the derivative of y with respect to x will give you the y du multiplied by the u dx. Now, find the derivatives of each of the following. This is a part. Why do we call it function inside a function? This is a question now. Y is 3x squared minus 2 all raised to power 3. You said let u equal to 3x squared minus 2. Now, why will not be the same any longer? Because you have represented the value here by u. So u will now be, y will now be u raised to power 3. If you're able to see, this is function 1, this is function 2. That is why we call it function of a function. That is just the reason. So therefore, if our u is 3x squared minus 2 and y is equal to u raised to power 3. Now, the first thing you do, you differentiate this u with respect to x, which will give you 6x. You don't need to explain one by one any longer, because if you don't get this, you just have to just go back a little bit, you get it. So now, the y, you will not differentiate y with respect to u. It will now give you 3u squared. So that is just, so you differentiate this u with respect to x, you differentiate y with respect to u. You now back to what we call a chain rule. Chain rule let us to know that the y, the derivative of y with respect to x is equal to the derivative of y with respect to u multiplied by derivative of u with respect to x. Therefore, it's meaning that the derivative of y with respect to x give you derivative of y with respect to u multiplied by derivative of u with respect to x. So now, what is for the value for this? We have 3u squared multiplied by 6x. So which can give us 3 times 6 times u squared times x, which can give us 18x u squared. So now, if this is 18, recall. If you are to recall that our u from the beginning, which I said is 3x squared minus 2. That is the value of our u. So at this junction, what you have to do now is just to substitute the value of u back to this place. So which will now give you that the derivative of y with respect to x will now be 18. You know, we have 18x u squared. 18x times u, 3s squared minus 2 all squared. That's just it. So therefore, which we have 18x bracket 3s squared minus 2 all squared. That is all. That is what we call the function inside a function. From these questions, the derivative of this will surely give you this. Let us also solve another one that have, so let's, he said y is equal to the square root of, you open a bracket, 1 minus 2s cubed. Now before we do this, there's something we have to, that's common in maths that makes some people find it so difficult, whereby it is not difficult. In every math, something like this kind of elementary part now, what you do here is you simplify first, which is 1 minus 2s cubed. You open, you close. This root means 1 over 2. So he has given you exactly that what you need. But it will not give you what you need if you don't simplify. So mathematics needs simplification first before you continue what to do. So this has obeyed the rules of the composite rule. Thereby, you now say let our u be 1 minus 2s cubed. That is the u. Our y will be u raised to power half. We have now obeying the two function. What do you now do? You differentiate the u with respect to x. You differentiate y with respect to u. You now obey the chain rule. Let's start. If our u is 1 minus 2x cubed, so therefore the u with respect to x will be minus 2 times 3x squared, which is equal to minus 6x squared. So, and our y from that place is u raised to power half. The y with respect to the u will give you half u raised to power minus half. We back to the chain rule to let us to know that the y with respect to the u, we multiply the u with respect to the x. That's all. So what is the value of y at this junction? The y du. The y du give us 1 over this onto half multiplied by the u ds give us minus 6x squared. So you know this 6 minus already. It will now be half times 1 over u raised to power half multiplied by minus 6x squared. So let's just try to put it together to be minus 6x squared onto 2 root u. If we're able to back to the laws of indices, that's what we give you. But if this can cancel this, if you agree, meaning that minus 3x squared over root u. If you can agree with this, so this is just a value. So now you recall that we have been able to represent u by this. So therefore the y with respect to x will now be minus 3x squared over the square root of u, whereby our u is 1 minus 2s cubed. That's all. That's just a value. So let's also solve another question, question C. Let's solve. It said if y is equal to 5 over bracket open 6 minus s squared all raised to power 3. Now, if you're able to study this question, you discover it come in form of fraction. But with help of indices, we're able to solve the problem. We said, let our u represent 6 minus s squared. Let our y represent 5 over u raised to power 3, which can be written as 5u minus 3. So with the help of indices terms, so let's differentiate u with respect to x. It will give you minus 2x. That's all. So let's now differentiate y with respect to u. We give you minus 15u minus 3 minus 1, which will be minus 15u minus 4. So we are able to got the two value now. Minus 2x minus 15u raised to power minus 4. So what needs to do is to apply what we call chain rule. Chain rule. And the chain rule let us to know that the y with respect to x is the y with respect to u times the u with respect to x. Therefore, and the y with respect to u give us minus 15. Minus 15, which is minus 15 u raised to power minus 4 multiplied by the u ds give us minus 2x. At this, you discover that minus we multiply minus will give us plus. 2 times 15 give us 30. This will give us 30x u onto minus 4. Before we proceed, recall that this can still be solved by indices. we have 30x all over u raised to power 4. And you're able to know that our dy with respect to x, it should now be 30x all over. Our u has been labeled by something already, minus x squared all raised to power 4. This is just the answer. I believe that with this simple explanation, you're able to get this is a fraction, but you won't see it as a fraction. You see it as that the law of indices can help in this sort of elementary calculus like this. So let's have another example of which you can be able to also come across. Let's have example D now. So which we have, let's say y is equal to 1 over root 1 plus x squared. Now, the first thing you need to do, you said let u equal to 1 plus s squared. Our y will now be 1 over root u, which can also be 1 over u raised to power half. In simplification by the law of indices, our y will now be u raised to minus half. That's all. So let's start differentiating now. Let's differentiate u with respect to x. We give you this. If you have to differentiate this, 1 is constant to give you 2x. So the y with respect to the u, we give you minus half onto u onto minus half minus 1. So the y with respect to x, we give you minus 1 over 2 u onto minus 3 over 2. So these are the two values that you need, that we need at this junction. So you can, let's simplify this to the last stage to make it easy. So if you have this, it means this can also be written as minus 1 over 2 times 1 over u raised to power 3 over 2. Can also be written as 1 over, let's say, minus, because of this minus 1 over 2 roots, because of the 2, u raised to power 3. So since we're able to get this, so then let's now apply our chain rule now at this junction. I said the y with respect to x is equal to the y with respect to u multiplied to the u with respect to x. So now, if you have to do this, meaning that minus 1 over 2 root u raised to power 3 times the 2x. You know our value here is 2x. When we differentiate it, the u with respect to x. So now, if you're able to study very well, you discover that in numerator there is a 2. In denominator there is also 2. This cancel this conveniently. Give us minus 1 all over minus 1 times x all over root u raised to power 3 can be written as minus x over root u raised to power 3. But recall that u equal to 1 plus s squared. So our dy with respect to x will now be minus x all over root, you open a bracket, 1 plus s squared all raised to power 3. This is the final answer. So this is in the composite rule. We stop in this example. So we still have to do more video that we are going to talk about the question and answer in elementary calculus. So don't forget to subscribe to this channel. Now we want to talk about product rule. If y is equal to uv, the derivative of y with respect to x will give you the value of this u. You write it. You now differentiate v with respect to x or respect to the function given to you. The derivative of v will multiply the whole value of u, plus it's as if you interchange that the whole value of v, which will be here, you now differentiate u with respect to s. That is what we call product rule. Let's have an example to solve so you can able to get this product rule very well. So before we continue, I also want to introduce this channel to you very well. The reason why you must subscribe, for at least if what we are doing is meaningful and it is good, I also want you to share and give it to people that need, share to the people that need it. You also subscribe to the channel. Remember, maybe just see this video from somewhere. The name of this channel is Olusegun Maths Clinic. So you subscribe to this channel. You can also see this video at Mike Bronze TV. You can see it at Mike Bronze TV. So Mike Bronze TV. In case you subscribe to this channel in YouTube, Olusegun Maths Clinic, Mike Bronze TV. These two channels, you can see our video there, whereby we solve at length the top mathematics topics. So I will also want you to encourage more to help us to subscribe to this channel, which is Olusegun Mathematics Clinic. So but it is being shortened to Olusegun Maths Clinic. So at the same time, maybe you have some topics that you want to know, you can comment to us at the comment section. You send it to us. We know what next to do about that. So that is all. So now let's continue the class. So let's have the first one, which is A, in product rule. We have been given the formula. Let's say y is equal to 3 plus 2x onto 1 minus x. If you want to analyze this, you said your u is this, your v is this. As I've explained early, the product rule, the value of u, you will write it, the derivative of y with respect to x. You don't need to write formula any longer. The formula is there. The real value of u, 3 plus 2x. That's all. Multiply by the derivative of x with respect to y. So if you differentiate 1 minus x, we have been moving a stage bigger than before now. We might not need to be writing this one out again. We just differentiate offhand. Now, the derivative of v will now give us minus 1 because this is x. So derivative of minus x will give us minus 1. Minus 1. So this is the plus. So what is the value of v? Is this 1 minus x multiply. So this is, you write the whole v back. So let's now differentiate u. 3 is a constant. 2x will now give you 2. That's all. Which will be minus, we multiply this, we have minus 3 minus 2x plus this. Sorry, it's not the minus is not affecting. It's not affecting this. It's only affecting the second one. So expansion of this because times minus 1. Yes. So minus 1 times this because this is plus from the board mass. Yes, good. So minus 1 because we are the derivative of v is minus 1. That's multiplying. So it's correct. So now plus So 2 multiply 1 to give us 2. 2 multiply minus x. 2 multiply minus x to give you minus 2x. That is minus 2x. Yes, good. So now at this, so therefore, let's collect the like terms. It will be the derivative of y with respect to x is equal to, so what are the likely commons? Minus 3 plus 2. Yes. Minus 3 plus 2 minus 2x minus 2x. Yes. Which will be minus 1 minus 4x. That is the final answer for that. So for this question, this is just, so you apply this stage by stage. Just follow the procedure as I just explained. No matter how question in product through, you will solve it. Let's solve another question. So when you have varieties of example, it's very easy for you to get very well. So therefore we have 1 onto 1 minus 2x plus 3x squared onto 4 minus 5x squared. Now, let's now explain one by one in another way now. Let u equal to 1 minus 2x plus 3x squared. Let our v be equal to 4 minus 5x squared. So let's now say the u with respect to x will give you, this is constant. This will be minus 2 plus 6x. Let differentiate v with respect to x. It will give you minus 10x. So now let's apply the formula that the y with respect to x is equal to, from our formula, which is u dv dx plus v du dx. So now from here, the value of our u is 1 minus 2x plus 3x squared. 1 minus 2x plus 3x squared multiplied by the v dx. So what is the v dx? It is minus 10x. So which is multiplied by minus 10x. So multiply, let's write it to the, because we are seeing elementary stage, multiply by minus 10x. Now, because tablet is not long, so plus, what is the value of our v? Our v is 4 minus 5x squared to multiply du dx. As at that time, when we differentiate, it gives us minus 2 plus 6x. It will be minus 2 plus 6x. That is the value. So now, let's start expanding in a logical way now. So therefore, in way of rewriting, to get it better, minus 10x bracket 1 minus 2x plus 3x squared. That is this. Now, plus this, we have plus bracket open 4 minus 5x squared. Yes, onto minus 2 plus 6x. So we can expand, but this will be the best way to leave the answer, because you have a long way. You also want to simplify again. So this is the final answer for this. That's just all about that. So let's be able to see it now. So in case we expand the answer, we still need to simplify. So we just leave it in that form, like that. So let's have another example. Let's have another example. Something say, if y is root x onto 1 plus 2x all squared. Now, you realize something that there's a composite now inside the product. So our u is equal to root x and our v is equal to 1 plus 2x raised to power 2. Yes. So therefore, if our u will now be s raised to power half and v will be 1 plus 2s all squared. Now, let's differentiate u with respect to x. Let's differentiate u with respect to x. So this is the u with respect to x will be, because you have to explain stage by stage, that is half onto half minus 1, which will be 1 over 2 onto s onto minus half. So why am I trying to slow at this junction is I don't want to make any mistakes. So that is exactly where you'll be doing yours too. So that's how you're able to get there. Don't rush at this elementary calculus. So therefore, which is equal to 1 over 2 s raised to power half. By the law of indices, we have 1 over 2x raised to power half. That is the u. That is the u ds. So let's find the v now, the respect to x. So in the v respect to x, if you are to differentiate this is composite rule. So now there's a little shortcut in composite rule which maybe you can talk about that one now to make it easy in a way to get the v dx. So the v dx, if our v is equal to 1 plus 2x all squared. So if you are to find the v dx, just say the v dx will be 2 to multiply these two. We come down. We multiply 1 plus 2x. Did the same 2 minus 1. Multiply by the derivative of inside, because it's a function inside function. So the derivative inside is 2. That's all. So it means that the v dx give us 4 onto 1 plus 2x. That is all about that. That's all. So therefore, let's now apply the formula that the y with respect to s that say u dv dx plus v du dx. So the first thing you do now, what is the value of our u? The value of our u is root x. So let's write it in a big form. The y dx. So the value of our u is root x. Now multiply the value of our dv ds is 4, as we got it the other time. 1 plus 2x. Now plus the value of our v from the beginning. The one I explained is a composite rule. 2x all raised to power 2. Now to multiply the value of the u, so multiply the u ds, which is the one I got, 1 over 2 root x. So in a simplified form, we have root x times 4, 1 plus 2x plus 1 plus 2s all squared over 2 root x. That is all. We are able to have simplified this. So this is the final answer. So because by the time you expand again, you still need to simplify back. So we have to stop in that place. So let's solve the last example in a product rule. So let's have another example, like if y is equal to x raised to power 3 onto 3 minus 2x plus 4x squared all raised to power half. So therefore, our u is equal to s raised to power 3. Our v is equal to 3 minus 2x plus 4x squared raised to power half. Now, the u with respect to x will give you 3s squared. Now, the v with respect to x, as I've said earlier, you have to apply the composite rule now, which is half. That half, we multiply the whole value again. 3 minus 2x plus 4x squared. The half, let me write it in a place where it will contain it. I don't want to shorten so you're able to get it better, because it will be long. It will be long, so it will be half. That half we multiply 3 minus 2x plus 4x squared onto half minus 1. It will give you minus half times the derivative of inside of this. It will give you minus 2 plus 8x. That is the derivative of this. So that is what we give you. So now, what we now need now is to multiply the two together. So, which we now have the y with respect to x will now be, so u dv dx plus v du dx. So now if you want to do this, so before we do this, I just want to remind you again that don't forget to subscribe to Mike Brooms TV and Olusegun Maths Clinic in YouTube, and also help us to share the video. At least after you have gained it, you have to if what we are doing is meaningful, also help us to share it to the people that believe they need it. So let's continue again. So therefore, in a way to now get the final answer, we now multiply one by one. Let's start multiplying one by one. Sorry for just erasing what I'm just writing. So that is the Olusegun Maths Clinic. Don't forget to subscribe to the channel. Now, so which is equal to, so the value of our u at this junction is s raised to power 3 times dv dx, which is the value of derivative of the one I wrote very long, this, which is half onto, as I've said earlier, 3 minus 2x plus 4s squared all raised to power minus half, which I said it's multiplying minus 2 plus 8x. So now plus v. And what is the value of our v? So the value of our v is, let's find it again. So the value of our v is 3 minus 2s. Is the one that long. 3 minus 2x plus 4s squared. Now multiply by du ds. The derivative of u is the one that gave us 3s squared. So multiply by 3s squared. Now, In case now to simplify this, some things occur which you discover that here 2 is common. And this one will come down. We have s cube onto s raised to the power 3 onto minus 1 plus 4x onto 2. I'm still considering this. So onto 2. Now over, you open a bracket, 3 minus 2x plus 4s squared all raised to power half. You able to see it? So now there is 1/2 here, which is this 2. That is the half. This half will come here. So because this can be easy to cancel this. That is just analysis I'm trying to do. So therefore, it will come down to this. So which is, so now plus 3s squared onto 3 minus 2x plus 4s squared. So now, this is over 1. We can find XCM at this junction. There is a way we used to do it, whereby it will make it to be easy. So we want to simplify. You know, these two has cancelled these two. So we just have something like this. Our XCM now is 3 minus 2x minus 2x plus 4s squared. So if this raised to power half, so this we cancel this straight. So to now remain 1 times this, making s raised to power 3 onto minus 1 plus 4x. Now plus. So by the time this multiply this, recall that this, so therefore, so by the time this multiply this, it will now, you know, this one, there is a half here, there is a half here. So this now, we now multiply this. It's as if you just have to multiply like a raised to power half times a raised to power half. It will give you a. So that is just the meaning we want to do now. It will give you a. That's what I want to do. So this will not be 3. It will be 3s squared onto 3 minus 2x plus 4s squared. It's over 1, but that is all. So the final answer will now be, you just have to simplify, s raised to power 3 onto, you can write this to be 4x minus 1 plus 3s squared onto 3 minus 2x plus 4s squared all over 3 minus 2x plus 4s squared all raised to power half. So that is answer. So that is how you need to. So you have to be careful to analyze this. I want to talk about the quotient rule in the elementary differential equation. If y is equal to u divided by v, the derivative of that y with respect to x, it will give you v du dx minus u dv dx, all divided by v square. Don't forget once again, Olusegun Mass Clinic, McBrown's TV. Subscribe. Let's now start solving some example. Find the derivative of each of the following. Y is equal to 1 plus s squared divided by 1 minus s squared. Our u is 1 plus s squared. Our v is equal to 1 minus s squared. So therefore, let's differentiate one by one. The u with respect to x, give us 2x. The v with respect to s give us minus 2x. Now, and we know the value of v to be 1 minus s squared, the value of u 1 plus s squared. So let's apply the formula now that the y with respect to x is v du dx minus u dv dx all over v squared. Let's substitute it right now. So our v is this 1 minus s squared. This is our du dv, and the u dv is times 2x minus, what is the u? 1 plus s squared times dv dx, which is minus 2, times minus 2x divided by our v at this is 1 minus s squared, all divided by v squared. So what we now do here, you expand, you have 2x minus 2s raised to power 3. This first minus, we multiply this, we give you plus immediately. So 2s times this will give you 2x. This times this minus 2s raised to power 3. That is all. We have 1 minus s squared all square. So this and this will turn to 0. So the y with respect to s will give you 2s plus 2s give you 4x all over 1 minus s squared all square. That's all. So that is the first example. Let's solve the second example. We are starting one by one, so you're able to get it better. The second example, the B part. So if y is equal to 3 plus 2x minus s squared all over root 1 plus x. So we have to solve it one by one. U is equal to 3 plus 2x minus s squared. Let's differentiate immediately. The u with respect to x will give you 2 minus 2x. We all know that is the derivative of 2x minus, yes, so therefore let's differentiate v now. Our v equal to root 1 plus x, which is 1 plus x all raised to power half. The v With respect to s, we give you half onto 1 plus x raised to power half minus 1, which is times, because it's a composite rule, times derivative of x, 1. So it still also gives us 1 over 2 onto 1 plus x onto minus half. So dv with respect to s, it will be 1 over 2 onto 1 plus s raised to power half, because this one is minus. We have all what we need at this junction, we have gotten it. So therefore, dy with respect to s, which is v du dx minus u dv dx over v square. Let's start substituting one by one. If our v is this, is root 1 plus x, making 1 plus x raised to power half. Multiply, we have to be careful, just step by step, so we can get it better together. So du dx, which is this, 2 minus 2x, that is du dx, 2 minus 2x, minus, now what is the value of u? 3 plus 2x minus s squared. 3 plus 2x minus s squared multiplied by. So dv dx is 1 over 2 onto 1 plus s raised to power half. That is all about that. So all over v. So that is all divided by v, which is 1 plus x raised to power half, at the same time now square. That's just what we need. Let's continue simplifying now, which we have 2 minus 2x onto 1 plus x onto half, now minus 3 plus 2x minus s squared over 2 onto 1 plus x all raised to power half. This is over 1 already, divided by 1 plus x. Do you know the reason? The reason is this half, by the law of indices, that says a raised to power m, at the same time raised to power n, it will give you a raised to power m times n, which is a raised to power mn. So the law applicable to this place. So if this is the formula,
incoming call from Little Angel.
If this is the formula that we are to use, you have to now re-simplify this place. We have to simplify better to find the XCM before the final denominator. Let's write it again in a better form. So you're able to get, we have to explain it one by one. We have to explain it in a way that fractions matter. So you now have is equal to 2 minus 2x over multiplied by 1 bracket 1 plus s all raised to power half over 1 minus 3 plus 2x 3 plus 2x minus x squared over, you do it one by one. That is 2 onto 1 plus s raised to power half. Therefore, the first LCM is 2 onto 1 plus s raised to power half all over 1 plus x. 1 plus x. So now, you do it one by one, you discover that this multiply by. So now, if 1 divided by this give us this, therefore, by the time this will multiply this half and this half will now become 1. That is all. We have 2 minus 2x onto 1 plus x onto half plus half. Now minus 3 plus 2x minus s squared. Now you start simplification back again, which we now have. So let's now simplify. We have this. So therefore, which is equal to 2. Let's remove 2 from here to have 1 minus x multiplied by 1 plus x. This has become 1 minus minus 3. Recall that when this want to multiply, we only multiply this by the top, but it also have multiplied by 2. So this one will be 4. This will be 4 brackets. So now, so it will now be minus 3 minus 2x minus s squared all over. So 2 onto 1 plus x all raised to power half. The total 1 plus x. Now, let's try to expand this. Recall that if you are to expand this on its own, it will just give you 4 onto 1 minus s squared straight. Minus 3 minus 2x minus s squared over 2 onto 1 plus x raised to power half times 1 times, the times will be in this place, times 1 over, this one will just be 1 plus x. So you just try to bring it near. So let's expand to, this will now give you 4 minus. So dy with respect to s is 4 minus 4s squared. Yes. Minus 3 minus 2x minus 3 minus 2x minus s squared. Now, so this 1 plus x, all this one raised to power 1, 1 plus s raised to power half. So by the time you go back to this law of indices to let us to know that a raised to power m multiplied by a raised to power m multiplied by a raised to power n, it will give you a raised to power m plus n. So therefore, it will now be, this will now be 2 onto 1 plus x all raised to power 3 over 2. That is all. So therefore, if you're able to study, let's start with constant. We have 1 4 minus 3 is 1. 4s squared minus 4s squared minus s squared. This is in the expansion of this. This is minus 3s. This will be plus. Yes. So this will be plus squared. So therefore, 4s squared plus s squared give you minus 3s squared. So remains 2x. So minus 2x. Yes. All over 2 bracket 1 plus x all over 3 over 2. So let's just try to rearrange it better. 1 minus 2x minus 3s squared all over 2 onto 1 plus x onto 3 over 2. This is just the answer for y with respect to x. That is how in quotient rules. That is how we solve it, the quotient rule. So it needs a patient way to solve the quotient, especially